Okay, so for your Unit 3 exam, right, it's going to be same format as all your other exams. You're going to have some multiple choice. You're going to have some written response. I'll go over the numbers here in a little bit. This exam is going to be more like chemistry, okay, especially in terms of how you prepare for it. The written response is almost entirely problem solving. Therefore, in order to properly study for this test, you should do a lot of problem solving. Okay, do you have access to a lot of problems? Yes. Okay, do you have the answers for all of them? Yes. So you should be doing those as a way to study. Okay, I mean, realistically, guys, by the time this unit is over, you should have done pretty much the entire workbook. Okay, for physics. If you haven't, then you're missing out on review opportunities. Okay. I also put the review package on Google Classroom, I think last week. Okay, it's got some old exam questions and things like that on it as well as some suggested activities. I would do those as well. It does not have like a practice test per se this time, right? But it's still got lots of questions for you to try. All right, so we started out this unit with the types and forms of energy. Okay, that's going to be tested in the multiple choice, so that'll be things like chemical energy and electrical energy, magnetic, okay, all that kind of stuff that we talked about the first day. Okay, also some multiple choice questions about mechanical energy, kinetic energy. Okay, not a lot of calculating per se, but more of the checking your understanding and things like that. There are some simple calculations in the multiple choice, but they're very simple, and there aren't many of them. All right. Do you need to know a lot of people's names? Not really. Like, I think you would recognize them. Okay, if they were in a question, you would recognize who was the right answer pretty quickly. So, okay, definitely know the different systems: open, closed, and isolated. Okay, we talked about those like the second day, I think. Okay, open systems exchange matter and energy with their surroundings. Closed systems exchange only energy, and isolated exchange one. Okay. And that day we also talked about the laws of thermodynamics. Okay, and we talked about heat engines and heat pumps and perpetual motion machines as well. Okay, there could be a written response question that is going to integrate those concepts together. Okay, basically checking how well can you explain how the laws of thermodynamics would allow for this machine to work, or would forbid the existence of this machine, okay, or something like that. Okay, so you need to understand that first law of thermodynamics is really the law of conservation of energy. Okay, the second law of thermodynamics is heat energy flows from hot to cold, okay, things like that. So be able to apply those to like a situation and explain what would happen in that situation based on your understanding of heat transfer, okay, and stuff like that. Okay, so that's definitely going to be somewhat in the multiple choice, but also somewhat in the written. Okay, and then after we talked about that, we talked about scalar and vector quantities. Okay, what were some scalar quantities that we went over? Time, distance, speed. Okay, what were some vector ones we went over? Velocity, displacement, acceleration. Okay, that's good. What are some other scalar ones? We didn't list all the scalar ones. Let's skip. Where do we go? Work and energy are also scalar. Force is another vector one, but we're not going to do one with force. It's just part of work energy theory, but understand that work and energy are also scalar. Okay? Okay, so there's our list, okay, of our vector quantities as well as our scalar quantities. Another thing to remember here is that day is the day we introduced V equals D over T. Okay? Should you expect to be asked to use that formula on the exam? Written response or multiple choice? Multiple choice. Okay, it's too easy to be wasted on its own on a 5-mark or 4-mark written response item. Does that mean it wouldn't be part of something? No, it could be part of a graphing question. Okay, if you had a position versus time graph or a velocity versus time graph, you may need to use that formula depending on the situation, type of graph, okay, etc. So definitely be able to use V equals D over T, okay, in one of those types of situations, or in a simple calculation in a multiple choice question, like somebody walks from my classroom to the end of the science hallway and then comes back only to the SpatCheck's room. And I give you the the distances or whatever and ask you to calculate speed. That could be something that would be a multiple choice simple calculation. Okay, something like that. Okay, and then after that, graphing. Graphing's huge. Okay, like Donald Trump, huge on this test. Okay, huge.
Did you graphing this year?
Yes, we did, and it's huge. Except for your hands. There's one. Okay, so it's a big part of the test. There's a lot of questions, a lot of marks on graphing. Okay, there are some graphs in the multiple choice. In the multiple choice, the questions are more about interpretation, less about calculation. In the written response, there's one of each type. Okay, so there's a position versus time graph, and there's a velocity versus time graph in the written response. Okay, you're going to be asked to do exactly the same things you were asked to do on your two labs. All right, so that may be that one of them would be just a linear relationship with a y equals mx plus b component to it. Okay, and you would have to be able to use y equals mx plus b to calculate something beyond the graph, which you guys can all do. Okay, or it could be a graph that has multiple sections, and you're asked to calculate something about one of the sections, or the whole thing is in total, or something like that. Okay, but absolutely the same things I asked you to do in the analysis for your two labs are what's going to be asked on the unit exam for each one of those graphs. Okay, so calculating displacement from the velocity versus time graph, calculating acceleration from the velocity versus time graph, calculating displacement and distance and velocity from a position versus time graph. Okay, all of that kind of stuff is all game for the unit exam. Okay, so keep all of that stuff in mind. Okay, my drawings are all terrible here. I don't even know what they meant. I'm going to erase them. I'll try that again, so they maybe make more sense. All right, if I have a position versus time graph, okay, and it looks like just this, okay, and I got y equals mx plus b for it, okay, the question might say something like, using the graph below and its equation, and I would like bold-faced, italicize, and underline that part, and its equation, okay, calculate the following things, okay, and I might ask you to calculate something like, what's the object's position at a time of 100 seconds, even if the graph maybe only went up to 50, okay? How would you do that? Use that formula. Don't use anything else. The question said, using the formula. So, use the formula, damn it. That's what it tells you to do. Don't think outside the box. Do it the way it asks, okay? Or it could say, how long would it take to reach a position of 500 meters when the graph only goes to 100? Okay, you're solving for y using that equation. Okay, if it says use the equation, use it. All right, everybody follow there. All right, if you get one that doesn't have the equation on it, then it might look something like this. All right, and then it could ask you, what type of motion is going on in one of the sections of the graph, or it might ask you, what's the acceleration during the last section? What's the acceleration during the last section? Okay, there are no numbers on the graph, and I'm asking you what the acceleration is in that section. It would be out of 1 mark, by the way. Yeah, it's 0. Do you see any curves on my graph? I think we need to study our graphs a little bit. Okay, there is no acceleration on this graph anywhere. This is a constant velocity in a forward direction. This is an object standing still, and this is an object moving backwards at a constant velocity. Okay, we better go over graphing on the weekend. Okay, you have all just been exposed. Okay, yeah. Okay, so yeah, we're definitely going to need to do that over the weekend. All right. All right, if I have a velocity versus time graph and it looks like this, then it's exactly the same as your speed lab. Could you calculate the displacement of that object? Okay. All right. Could you calculate the acceleration of that object? Yes. Would you use the equation of the line to do that? Yes, because it would be out of one mark and it would be right there, wouldn't it? Okay, because it would be the slope of the line. Okay, so these are all things we need to know. Okay, because that's the difference between even being able to start a question like that and being able to get all of the marks for a question like that. A graphing question, guys, is going to not be just one thing. It's going to be A, B, C, D, E. Okay, I'm going to ask you to do a lot of stuff with each graph. Okay, if you can't do the first one, then you're going to be in trouble for the others. So make sure you've gone over all that stuff. Really look at your lab. Maybe watch the podcast again, okay, to get your review done. All right. Or you could get, okay, a velocity versus time graph, right, that has multiple sections. Maybe it even goes down into the negatives or something like that. Okay. Maybe on a question like this, I might ask you, where does the object change direction? Yeah, right here and right there. Okay, when the velocity goes from being positive to being negative and from negative to being positive, that's where it changes direction. Okay, so make sure we know how to do that kind of stuff there. All right, acceleration. So being able to use the formula A equals VF minus VI over T. That's important. There are two problems in the written response dealing with that formula. And it could also be part of a graphic question. All right, so you need to be able to manipulate it. Guys, you need to be able to manipulate all of the formulas. Okay? If you have been writing down the manipulations for all the formulas on your formula sheet and not working on your algebra, you will be royally screwed on Wednesday, because you don't get to use your formula sheet. I give you a fresh one. Okay? Because I'm sure you've written a lot of stuff on that formula sheet by now. Okay? And so it has to equate. Okay? So you get a fresh formula sheet on the front of the test on Wednesday. Okay? So if you have not been working on your algebra skills, work on them over the weekend and come and see me Monday, Tuesday of next week, so that we can get them sorted out. You have to be able to manipulate equations, okay, for this test. Okay, and then work energy theorem. We spent a fair amount of time on that. What was my opinion of it? It's very, very important. As a result, there are many marks on the unit exam about it. Okay, not only in the written part, but also in the multiple choice. There's some questions asking you about what work is and about the work energy theorem and okay, things like that. So you definitely need to be familiar with the work energy theorem. The two problems that are on the exam are exactly like the ones we've been going over in class. Okay, work is either changing kinetic energy or changing potential energy. I'm asking you to solve for something to do with that. Okay, so that's going to be at least 10 marks. Work energy theorem in just the written. All right, 10, conservation of energy. That's what we've been going over. We're going to spend a little bit more time on that on Monday, okay? And then on Tuesday, we'll talk about efficiency, and then Wednesday is your test. So, conservation of energy, it seemed like we were kind of getting that. People were getting through that. So you'll get some kind of conservation of energy problem, okay? EI equals EF, okay? You know, roller coaster or sled on a hill or something like that, okay, and being asked to solve for HI or HF or VI or VF, okay, one or the other. Okay, and then lastly, and we haven't gone over this yet, okay, is efficiency. Okay, we talked about it when we did our lab yesterday. Okay, it's very simple. Basically, you just need to understand what it is. Okay, it's the percentage of your input work that actually does useful work. Okay, but we'll talk more about that on Tuesday. It's a pretty simple concept. Okay, so that's work out divided by work in, not loud winds. Okay, let's look at numbers here. Okay, so the entire test is out of 65, which actually makes it shorter than your bio test. Believe it or not. So there are 20 multiple choice questions, which is a lot less actually than either one of your previous two. They were both over 30. Okay? So you got 20 multiple choice, and then in the written response, there are 7 written response items, but many of them have an A and a B. Okay, so starting out with graphing, and then we got some acceleration, more graphing, work energy, conservation of energy, and acceleration. Okay. When I made this test up and built the key, I felt like it might be a little short. I didn't change it, but I felt like it was short. Okay? It only took me 14 minutes to make the key. Okay? That's short. Okay? 14. The way I gauge whether a test is like fair, unfair, long, or short is how long it takes me to make the key. If I can make the key in a certain amount of time, if I multiply that time by 3 and I still fit inside of a class period, then the test is long/hard. If I can multiply it by 4, then the test is much more in your favor, like fair/short. Okay? If it's 5, then I have to rebuild it because it's too short, too easy. Okay? You need to do the math on that. Okay? It's 4. Okay? That fits inside your class period. So it's, I think, just a tad bit short. Now, it might not be. If you really struggle with the math or something like that, then it might not be short for you, and that's why I didn't end up changing it. People felt it was short. I thought, okay, maybe people are going to struggle and take a long time with the problem solving, so I'm not going to add another question. Okay? There are 7 written response items. Okay? And like I say, the whole test is out of 65. So 45 marks in the written. And of those 45 marks, 16 of them are graphing. Okay, so a third. Okay. Actually, slightly more than a third are graphing. Okay. There are 9 marks on acceleration, 12 marks on work energy theorem, and 8 marks on conservation of energy. Okay. So that gives you a pretty good idea of how to weight your studying time. Okay, questions from you guys? No. It's definitive from one person. All right, for the test, things you need to bring with you. Okay, make sure you have a few pencils and your calculator. Do not show up here on Wednesday without a calculator. Okay, I have a couple of calculators I can lend out, but if more than that number shows up without a calculator, somebody will be the odd man out. Okay, and you don't want to be that person because, well, I don't know if you can do long division really quickly or square root things in your head. Yeah. So I wouldn't try to do that. I would just show up with a calculator. Okay, I think that'd be a good idea. So make sure you have that. Okay, and like I said, the formulas are all on the front page of the exam, so you don't and can't have your formula sheet. Okay, the same obviously will go on the final exam. Okay, on the final exam, everybody will get a fresh one of these. Okay, I printed these just the other day. You get a periodic table, formulas and solubility chart on the back. Everybody gets one of those. Okay, fresh one. You don't bring yours. No, you can't keep it. This is how I give. This is what I give to next semester. See how I save trees? Well, what would you do with it? You're gonna get a fresh one when you go to chemistry or physics one. Okay, so no questions from you guys? All right, well then you've got the review package that I put on Google Classroom that you could work on.
That's a lot of position and time graphs to get, so you have completely for all of them.
I have two.
Like after doing like what we just did, this is like relevant to the same time yourself.
All right, so I'll put that up there. Okay, but obviously you guys can call it up on your phones. Okay, it's I posted it last week, so if you just go backwards in the screen.
Would like intercontinental ballistic missiles be acceptable for C?
I suppose
I think I'll do
they go boom. Yeah.
Hey, you just say